Hi Neet Aspirants, welcome to Vari Medical Academy. Vari Medical Academy சார்பாக அனைத்து விதமான டாபிக் சார்ந்த ஒவ்வொரு வீடியோவும் இனி வரும் நாட்களில் உங்களுக்கு வரும். உங்களுக்கு இதை சார்ந்த சந்தேகங்கள், கேள்விகள் எதுவாக இருந்தாலும் கமெண்ட்ஸில் பாஸ் பண்ணுங்க. எங்கள் எக்ஸ்பர்ட் ஃபேக்கல்ட்டி மெம்பர்ஸ் போடுற வீடியோஸ் பிடிச்சிருந்ததுன்னா ஷேர் பண்ணிக்கோங்க. அந்த வீடியோ ரெகுலராக உங்களுக்கு வரணும்னா சேனலை சப்ஸ்கிரைப் பண்ணிக்கோங்க. தேங்க்யூ. Wish you all the best.
Yeah, good afternoon students. Today I am going to explain percentage of covalent character in ionic bond. Right ma? Percentage of covalent character in ionic bond. In ionic bond. But 100% ionic bond, 100% covalent bond is not possible. Some percentage of covalent character, ionic character is present. Now, percentage of covalent character in ionic bond explained by Fajans. The Fajans is the scientist. He explained the Fajans rule. Fajans rule. Actually, ionic compounds are soluble in polar solvents. Ionic compounds are soluble in polar solvents, and covalent compounds are soluble in non-polar solvents. Covalent compounds are not soluble in water. If ionic compounds are easily soluble in water, because it is the dielectric constant is more for water. Now we can take Fajans rule. What he explained here: cation and anion. Anion also having nucleus and cation also having nucleus. Here is anion having electron density. More electrons are revolving around the nucleus. Here is cation, anion are approaching each other. Whenever approaching each other, what is happening? The nucleus of cation attract the electrons of anion. The nucleus of cation attracts the electrons of anion. When it is attract, this electron cloud elongated towards cation. But at a time, whenever nucleus repulsions also present, whenever this nucleus is attracting it electron cloud, in the same way nucleus repulsions are there. When nucleus repulsion, this electron cloud, this total anion symmetry is disturbed. Now symmetry is disturbed means now distortion will be happen. Distortion means somewhat distortion. One side is more negative charge, one side is less negative charge. This type of elongation of, this is the actually the size, this one size, but it is elongated towards cation. This elongation towards cation is called polarization of anion. Means electron cloud is attracted towards cation. If more attracting power, the attracting power of cation is called polarizing power of cation. Now what you explained means the attracting power of cation is called as polarizing power. If this distortion of electron cloud or symmetry is disturbed, because this one is attracting, whenever attracting, what is happening? This one is elongated towards cation. Understand students, when cation anion are approaching each other, the cation of nucleus attract the electrons of anion. This electron cloud is elongated towards cation. In the same place, nucleus repulsions are there. Now symmetry is disturbed. If symmetry is disturbed means one is less negative, one is more negative. This distortion of anion, this elongation of electron cloud of anion is called as polarization or distortion. Electron sort of distribution, that is called polarization. It is called polarizing power of cation. Now polarizing power of cation and polarization of anion. Now we can discuss what are the points of cation. Polarizing power of cation. Polarizing power of cation. If polarizing power is more means covalent character increases. For example, what are the factors of cation means small size of cation. When small size of cation, what is happened when small size of cation means here is polarizing power is increases. Okay, what is the first factor? Small size. When the cation size is a very small means more polarizing power. More polarizing power means more distortion of electron cloud of anion. Now small size of cation means polarizing power increases. When polarizing power increases means covalent character increases. Covalent character increases. The first point, the small size of cation. When small size of cation means more pp means polarizing power. When polarizing power increases means covalent character increases. This one is the small cation anion. Understand, students? Okay. Next one, what is the another point? First point is the small size of cation. Next one is the larger charge or more charge on cation. If for example, if covalent character small size means I am taking lithium plus, sodium plus, potassium plus, rubidium plus. Here which one is the more polarizing power? Which one is the more polarizing power? Lithium to rubidium, the shells are increases. The shells are increases means size is increases. Which one is the smaller size? The smaller size is lithium. That's why lithium is the more polarizing power. When polarizing power increases, covalent character also increases. Next example, we can take a second A group elements, beryllium plus 2. Next one is magnesium plus 2, beryllium magnesium. Next one is calcium plus 2. Next to strontium plus 2. Here also from top to bottom the size is increases. In now beryllium is a smaller size of cation. Now smaller size of cation means polarizing power increases. This is the polarizing power order. Polarizing power. Next one is I am taking another one. Understand, students, this one? Beryllium to beryllium, magnesium, calcium, strontium. Now what is happening? Beryllium, magnesium, calcium means from top to bottom number of shells are increases. When number of shells are increases means what is happening? The nuclear attraction on outermost electron decreases. That's why the size is increases. We can take another example, Na plus. Next one is magnesium plus 2. Next one is Al plus 3. Here is Na plus 1 charge is there. Here is plus 2 charge. Here is plus 3 charge. Charge of the cation charge on cation increases. Charge on cation increases. What is happening? Polarizing power is increases. When polarizing power increases means covalent character increases. The first point is what I am discussing, small size of cation. Next one is charge on cation. If charge of the cation, here is Na +1, here is +2, here is +3, means +1 +2 +3 means charge is increases. Which one is the more polarizing power? Yes, and aluminum is the more polarizing power. Why, sir? Charge on cation increases. Charge means Al +3 is the more charge, na? That's why polarizing power increases, covalent character increases. The first point is small size of cation is favorable for a more covalent character. Next one is charge on cation also increases. Yeah, this one understand. Lithium is the smaller size. Small size means more polarizing power. Why is our aluminum +3? Aluminum +3 is the more charge is present. That's why more polarizing power. If polarizing power increases, covalent character increases. Another important factor is, this one I will raise, small size of cation. Next one is the elements having pseudo noble gas configuration. Pseudo noble gas configuration also covalent character increases. Write down next factor is pseudo noble gas configuration. Pseudo pseudo noble gas. Pseudo means false. Pseudo noble gas configuration. That configuration atoms are more polarizing power. If pseudo noble gas configuration means NS2 NP6 ND10 and -1 D10 or ND10 and -1 D10. We can write it, for example, copper plus silver plus Rm, Au plus. Copper and silver Rm. What is the electronic configuration, students? Copper 3D10 4s1. 3D10 4s1. If one electron removing, what is the electronic configuration? That is 3D10 only. 3D10. That's why is the NS2 NP6 ND10. That is the pseudo noble gas configuration. What are the pseudo noble gas configuration? Copper, silver, Rm. These are the more polarizing. If the atoms having pseudo noble gas configuration, this type of configuration, they are having more polarizing power. When polarizing power increases, what is happening? CC I am writing, covalent character increases. If you take Zn, zinc, Zn +2, cadmium +2, next to mercury, Hg +2. In this also, actually the zinc electronic configuration, 3D10 4s2. But here 2 electrons are removal. After 2 electrons are removal, 3D10 is formed. Here also the copper electronic configuration is 3D10 4s1. But copper +1 is given. Now +1 means 1 electron losing. This electron is losing to form 3D10. In the same Zn +2, this zinc to mercury also pseudo noble gas configuration. If pseudo noble gas configuration atoms are more polarizing power. If polarizing power increases, what is happening? Covalent character increases. These are the cation, polarizing power of cation. What are the polarizing power of cations? One is the small size of cation. Next one is the charge on cation increases. Next one is pseudo noble gas configuration. These are the more polarizing power. They are responsible for a covalent character. Next one is coming to the anion. What is the anion? Anion having polarization. What is polarization? Because of cation attract the electron cloud of anion, this electron cloud is elongated towards cation. This elongation of electron cloud of anion is called as polarization. If bigger size of anion means easily distorted, unequal, easily distortion. If small size is not possible. Now write the size of the size of anion, size of anion increases. Size is increases. What is happening? Polarization increases. Polarization is increases. When polarization increases, what is happening? Covalent character increases. Size of the anion. When size of the anion is increases, polarization increases. Easily distorted when the cation is approaching to the anion. Anion is the bigger size. It can be elongated. It can be attract means electron cloud is easily elongated towards cation. That is called as polarization. Now size of anion increases means polarization increases. Now covalent character increases. This one is the first. Next one I am writing size after charge on anion. Charge on anion increases. When charge on anion increases, what is happening? It is polarization increases. Polarization increases. When polarization increases means what is happening? Covalent character also increases. These are the points of anion. What are the points of anion? Bigger size. Size is very big. It can be easily distorted. If cation is nearby the anion, it will be very bigger size. It can be easily attract. If will more attraction means more distortion of anion because of bigger size of anion. Next one is the charge on anion also. Charge of anion increases, polarization increases, covalent character increases. These are the points about cation and anion. Now we can take what are the points we have to summary of. If polarization increases means covalent character increases. Covalent character increases. What is happening? Covalent character increases means solubility decreases. When solubility decreases, this is inversely proportional. Covalent character increases, solubility decreases. When solubility decreases means again melting point and boiling points also decreases. But another point, color imparting nature increases. Please remember this point, students. The covalent character increases means solubility decreases. Melting and boiling points also decreases, and color imparting nature increases. Next one is we can take example. Okay, we can take examples from question. Write the lithium chloride, sodium chloride. Next one is potassium chloride, lithium, sodium, potassium, rubidium chloride. Which one is more covalent character? In this regard, which one is write the order of which one is more covalent character. Covalent character. In this, lithium plus is there, Na plus and potassium plus and rubidium plus. Here is which one is the smaller size? Lithium is the smaller size. When smaller size of cation means more polarizing power. If polarizing power increases means covalent character increases. Now lithium chloride is more covalent character. More covalent character. What is the reason? Small size of cation. When small size of cation means more polarizing power. If polarizing power increases means covalent character increases. We can write the order. Lithium chloride is more. Next one is sodium chloride followed by KCl and rubidium chloride. If you take another example, next one is beryllium chloride and magnesium chloride, beryllium, magnesium, calcium chloride, next to strontium chloride, SrCl2. Which one is more polarizing power? What is the order? Here is beryllium plus 2 magnesium, beryllium to strontium, the number of shells are increases. When number of shells are increases means nuclear attraction on outermost electron decreases. That's why the strontium is more size. If the size of this one size is increases means less polarizing power. Now beryllium chloride is more polarizing power and more covalent character. If you take another example, BeF2 and MgF2. Here is which one is more covalent character? Here is beryllium plus 2, here is beryllium plus 2, here is magnesium plus 2. Which one is smaller size? Now BeF2 is the smaller size. Now polarizing power is increases means covalent character is increases. Now we can take FeOH taken thrice. Next one is FeOH taken twice. Here in two cases, one is Fe plus 3 is there, here is plus 3 charge, here is plus 2 charge. Which one is the smaller size? FeOH, Fe plus 3 is the smaller size. Now FeOH3 having more polarizing power. If more polarizing power means covalent character is increases. Next, we can take many examples. We can based on covalent character, we can decide based on polarizing power. When polarizing power of cation increases and covalent character is increases. When covalent character increases, solubility decreases. If you take calcium chloride, CaCl2, next one is MgCl2. Which one is having more boiling point? Boiling point means here is calcium plus 2, here is magnesium plus 2. Which one is the more polarizing, more covalent character? Magnesium chloride is the more covalent character. If more covalent character means here is a less boiling point. More boiling point means CaCl2 is more boiling point. Based on, we can decide whether based on size of cation, charge of anion, we can decide the covalent character of the compounds. But 100% there is no ionic bond, covalent bond is available. But some percentage of covalent character, ionic character is present. If you take ionic bond, some percentage of covalent character is present. If you take ionic bond, covalent character is present. If you take covalent bond, ionic character is present. Percentage of ionic character in covalent bond explained by dipole moment. Dipole moment will explain ionic percentage of ionic character in covalent bond. These examples you have to remember it, BeF2 or MgF2 based on concept. What are the how to summarize what are the important points about Fajan's rule, how it is summarization of what are the important points if covalent character increases based on covalent character. When covalent character increasing, what are the points, what are the favorable conditions? For cation I am writing, here is anion I am writing. For covalent character increases means here is a small size of cation. When the size of cation is small, more polarizing power, more covalent character increases. Next to another point is large or more charge on anion. Anion is more charge. More charge or large charge on cation. Not anion, cation. Next point is pseudo noble gas configuration. Pseudo noble gas configuration. These are the important points about cation. If pseudo noble gas configuration means NS2, NP6, ND10. This configuration is pseudo noble and large or more charge on cation. Next to small size of cation. Next to, for example, this is the cation I am writing. Here is anion. What are the anion characters? Here is anion is a larger size or larger size of anion. If larger size of anion means polarization increases. These are the polarizing power. This one is polarization. We can take polarization. Now larger size of anion or more charge on anion. These are the important summarization of covalent character, and use this videos, and you have to get the good marks, and we are only for you are getting good marks, we are trying how to improve the scores in NEET exam. Please subscribe it, comment it. Thank you. All the best to your preparation.